Okay, MYP4 Unit 3, Chapter 3 is all about calculations with standard form numbers. So for example, multiplying 3.2 times 10 to the power of 6 multiplied by 2.1 times 10 to the power of 9. So I kind of put brackets there just to separate off the numbers, but in fact with multiplying, the order you do things in doesn't matter. So those brackets aren't really doing anything other than to separate two standard form numbers. And because the order doesn't matter with multiplying, I can rewrite that as 3.2 times 2.1 times 10 to the power of 6 times 10 to the power of 9. So I put all of the regular decimal numbers at the start of that calculation, the 3.2 and the 2.1, and I've coloured those in green just to make them distinct from the power numbers, which I've put in purple. So the power numbers I've put at the end of the calculation, 10 to the power of 6 times 10 to the power of 9. So I've just changed the order of everything so that the power numbers are all together and the regular numbers are all together. So 3.2 times 2.1 is 6.72, and 10 to the power of 6 times 10 to the power of 9 is 10 to the power of 15, because the rule is that you add the powers when you're multiplying powers of the same thing. 6 plus 9, 15. So the whole thing comes to 6.72 times 10 to the power of 15, which is in standard form, so that's an acceptable final answer. So then I gave this question in class, which was 8 times 10 to the power of 4 to be multiplied by 4.1 times 10 to the power of 6. So I wrote that out, and then I changed the order of everything. So I wrote all the regular numbers first, which I've put in red this time, 8 times 4.1, and then all the power numbers, which I put in purple this time, second, 10 to the power of 4 rather, times 10 to the power of 6. So it's just changing the order of the calculation. 8 times 4.1 is 32.8, and 10 to the 4 times 10 to the 6 is 10 to the power of 10, because the rule is you add the powers. 4 plus 6 is 10. So we got 32.8 times 10 to the power of 10, but the problem with that is that it's not in standard form, because for standard form, the first number has to be between 1 and 10. So what I've done is made that first number 10 times smaller. So instead of 32.8, I've written 3.28. But because I've done that, the other bit needs to be 10 times bigger. So instead of 10 to the power of 10, I've made it 10 to the power of 11. So the final answer in standard form is 3.28 times 10 to the power of 11. Okay, this is how I did dividing. So 8 times 10 to the power of 11 to be divided by 4 times 10 to the power of 3. Now you can actually write that out as a fraction, because the line in a fraction just means divide. So I can write that as 8 times 10 to the power of 11 over 4 times 10 to the power of 3. With it written nicely lined up as a fraction like that, I can separate the regular number and power number calculations. So I can just do 8 divided by 4, which gives me 2, and 10 to the power of 11 divided by 10 to the power of 3 is 10 to the power of 8, because the rule is that when you are dividing powers of the same thing, you subtract the powers. So 11 minus 3 is 8. So the final answer is 2 times 10 to the power of 8, and that's in standard form. So then I did this question where similar sort of structure, one number divided by another. So I wrote it as a fraction, 3.2 times 10 to the power of 6 divided by 6.4 times 10 to the power of minus 3. This is a bit trickier for a couple of reasons, as we'll see. So first of all, I'm doing the regular numbers, 3.2 divided by 6.4, and that's 0.5. And then I'm doing the power numbers, 10 to the power of 6 divided by 10 to the power of minus 3 is 10 to the power of 9, because you're doing 6, take away because you're dividing powers, and then minus 3 because it's already a minus number. So you're doing 6 minus minus 3, same as 6 plus 3. So you're getting 9. So 6 to the power of 3 divided by 10 to the power of 6 divided by 10 to the power of minus 3 is 10 to the power of 6 minus minus 3, 10 to the power of 9. So the whole thing comes to 0.5 times 10 to the power of 9. But there's a problem with that. It's not in standard form because 0.5 isn't between 1 and 10. So what I've done is made it 10 times bigger. So instead of 0.5, I've made it 5. But then I need to make the other number 10 times smaller. So instead of 10 to the power of 9, I've made it 10 to the power of 8. So final answer, 5 times 10 to the power of 8. And that's in standard form. Okay, the next thing is adding and subtracting. And the rule for this is that there really is no rule. So 3 times 10 to the power of 4 plus 6 times 10 to the power of 2. You've just got to separately evaluate the two bits. So they come to 30,000 and 600 respectively. And then just add them up, which comes to 30,600, which if you want to put it into standard form, using the same method as before, is 3.06 times 10 to the power of 4. So the rule for adding and subtracting powers is that there isn't really a simple rule. You've just got to work through it. So there was a booklet with some questions from old exam papers, which I've set as a summative assessment. So it's called Questions on Standard Form. You need to have a go at those.